Hey guys, it is final countdown, day 3 days left until the exam. Sorry to get this out so late, but I want to make sure that I get something to you every day. So here's an example question. I'm going to call this mock exam question number 1. And this has been modified. This was actually a question that was on an actual test in the past and has been tweaked for the format of your test. So make sure you have your one-page summary nearby, your notes, a formula sheet, your calculator, the tables if you want them, be ready. And I will upload a blank version. So if you want to actually do the blank one first as a full practice test and then look through my answers. So let's look into the answers here. So question number 1, for many years, the medically accepted practice of getting aid to a person experiencing a heart attack was to actually have them place the emergency call administer chest compressions plus mouth to mouth. So a person's laying on the ground here, right? And another person is pushing on their chest, sitting there pushing 1 and 2 and 3 and 4 and 5 and 6. And then shifting over and giving mouth-to-mouth resuscitation, okay? And so it was alternating back and forth breaths and then compressions and then back to breaths and then compressions, okay? That's what's happening here. This is true to life. However, some new researchers have believed something. So they have a sneaky suspicion that just chest compressions, so if a person was giving CPR, that if they just gave the chest compressions, that actually would be more effective. So if you think about that for a minute, so they've actually written H-sub-O and H-sub-A for you. The survival rate of the two treatments is exactly the same, so we have to assume they're the same. And the researchers believe that just chest compressions alone by themselves would actually be a higher success rate. And this is probably contrary to what you'd be thinking. Because you'd be thinking, well, why is everybody having these trainings and why are people thinking that this breathing is an important part? Okay, so during the study in 1990, it was conducted in Seattle where they took 518 cases and they were randomly assigned. So that means that it was an experiment because random assignment has to do with treatments, and that means an experiment. 278 were given chest compressions plus mouth-to-mouth resuscitation, and the other group of 240 just got chest compressions. So out of a total, 64 survived the heart attack, which is kind of sad, but you pretty much know if you're having a heart attack, there's a high likelihood you're going to die of a heart attack. So these were people that before the invention of mouth-to-mouth resuscitation or CPR wouldn't have lived at all. So every life saved is one more than would have been saved. Okay, so I made this sketch, and you wouldn't even need it for the question, but it helps me think about what's happening in the problem. And they could have asked, so let's prepare. Out of the 518, we gave random assignment to each group, right? And 288 got chest compressions plus the mouth-to-mouth resuscitation, and 240 got chest compressions only. So now, at the end of the experiment, we're going to compare our results. And we noticed that we got two sample proportions. We got the proportion that lived in the first group and the portion that lived in the second group. Okay. Now, I just kind of did that in my head. So let me actually crunch this out now that I'm by my calculator. Yeah. Yeah, that's almost 15. Okay. So now let's get to the question at hand. It says, explain how the design of this experiment would address replication and what is the benefit? So we know that there's natural variation. So if we did an experiment of two groups of people, even if they were exactly the same, there's going to be some amount of variability. So what you have to decide is this the same thing as just natural variation? So what does replication do? Replication allows us to compare the treatments. So we've replicated the same conditions in each group except for the different treatments, which this would allow us to compare the treatments effectively. Now let's say you had this question on the test and you didn't know what replication was. I would suggest having your book, your textbook, open to the glossary. I've actually, in some of these practice tests, used it. So the glossary is in the very back of the book, and I think that that's worthwhile. So that's a test tip. Okay, next question says, what is the variable of interest? So what they're really asking is, well, compare results. What is it that you're even measuring? So the variable of interest here is whether or not a patient survived. So 29 survived out of 288, and the rest of them did not. 35 survived out of 240. So remember, the word variable means whether or not. We have to talk about it as if it were a variable, meaning they could have survived or they may not have survived. So that's a variable. That's what varied. Okay. So I answered the first question here. What is a variable of interest? Now I'm going to ask, what type of graphical display would be appropriate? So just back on our Unit 1 notes, right, we know that if it's categorical data, the appropriate display would be a segmented bar graph. I could have also taken a mosaic plot. And there you go. And these examples are shown, but notice that they didn't ask for them in the question. So this just gives me a chance to kind of review this with you guys. Notice that bar 1 is chest compressions plus mouth-to-mouth resuscitation. Bar 2 is a little bit higher, right? Because 15.15 is higher than 0.10, and that's chest compressions only. Now, what else besides a segmented would be a mosaic plot? So this group had slightly more people, and so that's why this would, right? The first group had more people than the previous group. Okay, part C says, what is the name of the appropriate significant test? So this would be in Unit 6, right? We're doing 2 sample because we have 2 groups, right? Sample 1, sample 2. So this is a 2 sample and the letter's Z because we're doing a proportion. So a 2 sample Z test for P1 minus P2. Right? We're trying to figure out, is there a difference between the 2 groups? We have to assume there is no difference in our H sub O. And our H sub A is, we believe there is a difference. We believe that, that the proportion who survives, did I write that down? Produce higher survival rate. Yeah, that's right. Okay. Now, let's get to the next parts. In a normal test, we'd be done, but we'd also have 6 free response. So this is a beefy question 1, so let's keep going. So part 2 states, the test resulted in a p-value of 0.0761. Notice we didn't have to calculate that like we normally would in class. So they're trying to make this test calculator neutral. So we really should be prepared to interpret the number, maybe not necessarily calculate it. Okay, so how do we interpret a p-value? A p-value means assuming H sub O is true, but that's generic. So I have to go back to the problem and say what H sub O is. So assuming the survival rates for the 2 treatments are equal, right? That's H sub O. So assuming the survival rates for the 2 treatments are equal, there is a 0.071 probability that we would observe a difference in these sample proportions of this or more extreme just due to random chance. So that's right off of my cheat sheet. I'm just copying it and making sure I have my context in there. Okay, so now Part E says, based on this p-value and this study design, what conclusion can be drawn? Okay, and we're going to use the regular significance level. So notice, this is back to our script and our posters on the wall. with a p-value of 0.071, which is greater than 0.05, we fail to reject the null hypothesis. We do not have sufficient evidence to support H sub A. So that's what it says on our poster, but we have to say what H sub A is. So notice they've said it for us. H sub A is that the treatment that uses chest compression alone produces a higher survival rate. So that's what I've copied here. That the treatment that uses chest compression alone produces a higher survival rate. Okay? Now, last question. And I see these types of questions more prevalent because, again, we're not calculating, we're interpreting more. And we don't need a calculator for this. Notice since we walked through door number 2, right, we failed to reject the null, then we have a chance of committing a type 2 error. So you'd get partial points if you identified the right error test. But again, we should be using our scripts and our notes to explain what does it mean when you commit a type 2 error. So we've made a type 2 error since we did not find convincing evidence for chest compressions alone. But if in reality, H sub A really was true, so that's what our notes say for type 2 error. H sub A really was true. So we go back and say, well, what was H sub A? It's the treatment that uses chest compression alone really does produce a higher survival rate. So that's what I've said. What if in reality, chest compressions really do alone produce a higher survival rate? Then we must talk about the consequence. So the consequence with this would be we were using a less effective approach than we could have had. So this could have led to loss of greater life. The other thing I notice is it could lead to transferring germs, right? We're out there thinking that mouth-to-mouth resuscitation is more effective when in fact it really isn't. So especially in the case of COVID-19, our paramedics would be giving mouth-to-mouth when in fact only giving chest compressions was more effective. So that would be a highly more preferable way of giving a treatment, especially if it leads to higher survival rate. Thanks for joining us, guys. Can't wait to talk to you tomorrow. Take care.